Right, students, we're busy with 15.3, tangents and circumscribed angles. Two new concepts. We haven't talked about that. What is a tangent? Tangent intersects the circle in exactly one point, the point of tangency. So if I can quickly draw here, if we have any line or line segment going through a circle, it will always intersect twice. Intersects with the circle twice. But if I move this line, there it is, twice, and I move it a little bit further, it will only touch the circle once. And when it intersects the circle exactly in one point, then we can call this segment only once a tangent. And this point where it touched the circle is the point of tangency. Right, that's what we're going to talk about today. Before we start, let's just quickly take a look at the other theorems we've been working with. Inscribed angle theorem, look at my abbreviations. Inscribed angle theorem says this: inscribed angle is half of the measurement of this arc. So this is degrees and that is degrees. Inscribed angle always half of the measurement of the arc that it subscribes. The inscribed quadrilateral quad theorem, when I have a quadrilateral, 4 different vertices is on the circumference of a circle. What do we know about this quad? The opposite angles are supplementary. X plus y must be equal to 180 degrees. And I could have written down the x and the y there too. This opposites, the pair of angles, will also be supplementary. We also talked already about the congruent corresponding chords theorem. This arc is definitely the same measurement, like congruent than that arc. What can we say about the chords that is subtended by these arcs? And these two chords will also be equal. Okay, if we have arcs equal, then the chords that are subtended by that two arcs will also be equal. Now today we're taking a look at tangents. The tangent radius theorem. What does that say? I have a tangent here, it's only making contact with the circle once. And then from the center I draw a radius to that point of contact, that point of tangency. And eventually this theorem states that the tangent and the radius will always be perpendicular on top of each other. 90 degrees angle, I could have made it this side. Because it's a straight line, both angles must give me altogether 180. So this one is 90 and that one is 90. We like to say that a radius is perpendicular to the tangent. Or the tangent is perpendicular on the radius. Next one, circumscribed angle theorem. In the beginning we had an inscribed angle theorem. This one, circumscribed, my angle is on the outside of the circle. So this angle, if I make this one x, I want to know what is the relationship with these two corresponding angles. Well, not corresponding, they're opposite each other. We already have our tangent radius theorem. Now this is a tangent, it's only making contact once. This is also a tangent, it must be tangents, otherwise this theorem doesn't work. This is a radius, here's my center of the circle, so I know this one is 90 degrees. I know this one is 90 degrees. Tangent perpendicular on the radius or radius perpendicular on the tangent. What do we know about the four angles of a quadrilateral? If I add all four these angles, I will get 360 degrees. We've done that, well, hopefully in the previous work. So eventually, these two angles will also be supplementary, equals 180 degrees. Of course, these two, 90 plus 90 is 180, plus another 180 will give me the 360 that this quadrilateral or the interior angles will add up to. So my circumscribed angle theorem, when the angle is outside, then the opposite one that is inscribed and it's at the center, it's a center angle. These two will be supplementary. The two tangent theorem, last one. Here I have a tangent, only touching once, tangent, only touching once. What can I say about these two tangents? We say this line segment, only talking from A to B, and from A to C is definitely tangents. Then, what can we state? We can say that these two tangents, if I take it from A to C, I don't worry about the rest, from A to B, they are congruent. From A to B, congruent from A to C. Those two line segments, the two tangents, will be congruent. Right, let's do a few examples in the next video.